Okay, continuing back with inverses here, just picked out a couple of homework problems you might be having discussions about or whatever. So I'm going to just try to keep this color-coded. I'm going to do red as the original function, and I'm going to do the purple function to be the inverse. So whatever, let's just do it. X equals the log of base, what? 2, and then the letter y plus 5, right? And ultimately our goal is simple. Replace the x's and y's and then solve for the new y. So of course the new y is right here. And the question is, well, how do you cancel out a log? Well, the inverse of a log is exponential value, right? So the base is what it's all about right here. So the base of this logarithm is 2, so to undo the log, we're going to simply take 2 to the x power, and we're going to raise everything on the right side to the 2 power, which is kind of pointless. Well, it's not really pointless, but you'll see. Log of 2 of y plus 5. And then notice what happens when you have 2 raised to the log of base 2. Since the base and the exponent base are the same, this whole thing just cancels, and the exponent just drops out of the sky magically, I guess. So you have 2 to the x power. Whoops, sure said I was going to do that in purple. Dang it. There we go. So we have 2 to the x power equals y plus 5. And now solving for y is pretty easy. So we have 2 to the x power subtract 5 equals y. And this is the inverse of our original function. So if this is called, it's just a little notation, if this was f of x, the original function here, this inverse would be written like this, f to the negative 1. That's another way of writing the inverse function. You need to be familiar with both of them, okay? Alright. Let's take a look at maybe a couple of the derivative problems if we can. See what that looks like. Let's just erase this problem here, and we'll start with I don't know. We could look at number 4, the derivative, huh? All right. So let's do this very methodically, this first problem here, and eventually you won't have to be this meticulous with it, but f of x, we're going to do this in red, right? And f of x is equal to cosine of x. Okay, the cosine of x. Alright. And notice, if we're trying to find the derivative of the inverse, we don't have a letter for it. We can just call it f of negative 1. Okay? Now, the one thing you need to remember is that if I call this x, since these are inverses of each other, every time you see x, you're thinking y on the original function, right? So keep that relationship in mind and you'll be okay. So what they're asking us to find is find the derivative of the inverse when at x equals the square root of 3 over 2. Alright, so when x is equal to the square root of 3 over 2. Let's write that in red because that's what we're talking about here. When x equals the square root of 3 over 2. Alright, so let's keep everything separate here. Well, if we're saying when x equals the square root of 3 over 2, on the inverse, we're going to have to switch the x's and y's, right? So let's ask this question. When does the square root of 3 over 2, or when does the y value equal the x value, right? The cosine of x. And this is all in the original, right? So if you think about your finger trick, when does cosine give you the square root of 3 over 2? And hopefully you'll say that that happens at, what, pi over 6? Pi over 6. So the cosine of pi over 6 is equal to the square root of 3 over 2, right? So when we're talking about the inverses here, our x is going to equal to pi over 6 when our y value for this one is the square root of 3 over 2, right? Okay, so let's take a look at the derivative. And remember, the derivative formula for the inverse just says to do this. Let's see, it says to do this. It says to find the derivative of the inverse. And you can refer back to your notes. Since it is the chain rule, let's see exactly how he phrased it. Okay. So we have the inverse, the derivative of the inverse. So we'd have that little -1, whatever our derivative mark right here, is equal to 1 over the derivative of the original function. Alright? Whoops. Let me write the derivative here. Let's back that up a little bit. So we have the derivative of x, right? And remember, since we're talking about inverses, all we're going to do is switch the x's and y's, which we've already done. So let's move on here and let's take a look at plugging in our values. Well, the first thing is, what is the derivative of just f of x? Remember, f of x is cosine of x, so the derivative of that would be 1 over sine of x. But it's not positive sine, is it? Negative sine of x. And that's equal to the derivative of the inverse. Okay? Now, we've already found our x and y values are switched, right? We've already switched them over here. So you would say that the derivative of the inverse, and you just plug in pi over 6 and what is pi over 6? If you take the sine of pi over 6, you get 1/2. So let's do this here. So we have f inverse, the derivative of f inverse, is equal to 1 over -1/2. Remember, the sine of pi over 6 is 1/2. So what is 1 divided by -1/2? And you should get the answer is -2. So that's the derivative for this inverse. Okay. Let's take a look at number 6. And then maybe this video is getting a little long. Yeah, let me stop this video and we'll look at another one in the next one.